afternoon, good evening, good morning from wherever you're watching this video from. This is King of Mathematics once again. Today, I'll be taking a topic in mathematics called the binary operation. Now, the binary operation, when you want to learn much about this, the first thing you need to know is the definition itself of what binary operation means. So what is binary operation? Like I have on the board, binary operation simply means the rules of combining any two elements of a given non-empty set. As you all know what a set is. Now, when you talk about combining, combination deals with not just one thing. Just like if they say a man and a woman is combining, that means it's going to be two different entities. You understand? Just know that it's going to be involving two things. That's what combination is talking about. Combination is not between one person, because between two persons. Now, it is always denoted by some mathematical symbols. What mathematical symbols are used in binary? That's when you see asterisk, something like this. You have made, you see something like this, like a triangle, small triangle. These are signs and symbols that we are talking about. I know that you have met with something like this, like they are all symbols. They are all symbols. So then there are still other symbols. This one is normal circle. You have met circle, the X inside it. You have met circle with dots inside it. They are what? Symbols, depending on what they want to give you. Then this X is multiplication, this one is minus. So we've seen minus multiplication. This one is still a dot. You can have a circle with plus inside it. You understand? So they are just symbols. They are symbolizing something, and every operation definitely means something. Definitely means something. So now let's see how some of these operations are being done. And for example, now if you are talking about a binary situation, let's see, you can have something like this. A, small a, you use small letter A. You understand? You use small letter. Then operation, then I can make use of asterisk. Operation B, I can give it a particular mathematical equation that when anytime you are operating A on B, what you should do is to do A, I can say AB, or let me say A plus B. That is, anytime you have A to be an entity and B to be an entity, you want to operate it, then you say A plus B. Let's say my A now, I'm giving 3 operation 2, and they ask me to find the solution. How will you find your solution from this? They will have given you this operation, and you should follow this operation. And anytime you see A operation B, the answer, to get the answer, is always A plus B. So likewise, I have 3 operation 2, which means what you are expected to do is A is 3 and B is 2. That will now be 3 plus 2, which will give us 5. So that will be the final result for such answer. Let's see. Let me call this one example 1. You can have another one, example 2, that A operation B is equal to A times B. In a situation whereby your A, let's say A is 2, I ask you to do 2 operation 3. You are going to do this one just because that you know that A operation B, and you've done it for example B. You have to look at what they asked you to do this time around. In this one, it was addition. In another place, it might be multiplication. So if this place is multiplication, our A here is 2 and not 3. So that is 2 times 3. And here your final answer will be 6. Are you getting the point? Because I want to explain in a way that when you get to class, you actually understand it well and you won't have any problem, because that's the major reason why this class is being organized, for learners to learn more things that they are unable to learn from their educators. They should learn it online here. Let's see another interesting one. Let's say I'm changing the sign now, and I'll use example 3. Let me use this one this time around. A operation B, if I ask it to be A plus B minus 2AB, it might be my operation for this one. So if you want to handle this, how are you going to solve it? This time around, let's say if then they now ask find if A operation B is equal to this, find 5 operation 1. So therefore solution, in that case, what's your A? A is, so I will now say 5 operation 1 is equal to A is 5 plus 1 minus 2 times AB means A times B, 2 times 5 times 1. What is 5 plus 1? That's 6. So you have to have knowledge of BODMAS as well, how to do your operation and how to do some subtractions, also like directed numbers. For you that you don't know how to, what the result of minus 2 plus 7 is going to give you, you might have issues here. Or what is going to be minus 5 plus 2, you know that's going to be minus 3. But if you don't know how to operate things like that, you have issues in this. That's why sometimes in further math or mathematics, you still have some inbuilt topic inside that new topic that you are learning. So there's always a foundation that you are meant to know. That's why from primary school you are being taught some basic things. So let's see what's going to happen here. Your multiplication is going to be involved now. What is 2 times 5? 2 times 5 will give you 10. And what's 10 times 1? 10 times 1 will still be 10. So this is now going to be 6 minus 10. What is 6 minus 10? For those of you that you don't know much about mathematics, you say this is not possible. How can you subtract 10 from 6? But it's possible. But what's going to happen is that you'll be, the way I teach my own learner is that see it as the amount you have on ground, and this minus is borrow. The person wants to borrow 10 naira from you. You have 6 naira. Or let's say you are in abroad and you're watching this video, you have 6 pounds, and so a friend of yours needs 10 pounds. Now, if you give out your 6 pounds, how much left do you need to balance the 10 pounds for your friend? Or how much naira do you need to balance the 10 naira for your friend? Definitely you need 4 more naira. So because you need it, or probably for it to be complete, that's going to give us a negative. So that's going to be minus 4. So that will be your final answer. I want to believe you are getting the point. You are getting the point gradually. You are getting the point gradually. Now, these are means by which different operations can be done. But proud is, there are still some inbuilt stuff in binary operation, and that's why I'm going to go into some basic law of what, or let me say basic property of binary. So let me rub the board so that we will know those basic law, basic property. So let me start from, okay, I can still use this space. So the first one is what I call a closure property. So if you've been attempting some past questions, you will have seen a situation whereby they will ask you that A is being operated on B, and is A operation B, is it closed or not? How will you now know whether it is closed? It is closed or not? This is how you will know. So Let me write a short note here. Sorry, permit me to stand up and write this for you. So a set D, let's use D, is said to be closed under the binary operation let me rub this place off. Is it showing? Oh, that place is not showing. Let me just rub it off and write it there. Let me write it in this place so that we can see it properly. So what I was writing there is a set is said to be closed under binary operation. Let's use this. If for any A operation B equals C, we have A, B, and C is an element of D. So before I start the example, let me quickly explain something to us of like what I wrote here. I said a set D is said to be closed under the binary operation this if for any A operation B equals C, A, B, C are elements of D. That is, you can find A, B, and C inside D. Like now, this A, this B, this C. If you can find them as elements of D, you will be given a set for D. Like now, if I give you D to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'll give you an operation to solve for me that A that this is called to so and so. If you cannot find the answer, that you are getting inside that set of D that I've given to you, then you say it's not closed. But if you can find that answer inside D, then you say it's closed. What am I saying in essence? Let's say an example. Let's say if A let's say if A operation B is equal to A plus B minus AB, and I tell you that G is equal to set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And say find A operation B if A equals 1, B equals 2, and is A operation B closed under set D. So how will you now confirm? Then we've given us, that means what they want me is that I should find A operation B. That means that will now turn to one operation 2. Let's find what one operation 2 is. According to the law, that will give us 1 plus 2 minus 1 times 2. So 1 plus 2 is 3. 1 times 2 is 2. This one will give us 1. The fact that we are getting 1, and 1 is part of the element of D, then you say, therefore, 1 operation 2 is what? Is closed. Because this 1 is also part of D. But in a case whereby you are not getting an answer that is part of D, then you say it is not closed. I don't know if you are getting the point. Then you tell them that it is not what? It is not closed. That's what you will do. I will give you time to check that before I go to another example. Alright, so let's see second example so that you know we've done the one that is closed. Let's now see the second example. If I say A asterisk, that's the operation I want to use. A operation B is equal to AB plus B. And A, B is an element of odd numbers. Now find two operation 3 and denote if closed or not. So let's see that one. If you're going to solve this one, we will follow the law. I want to believe first you know what odd number means. When you're talking about odd numbers, you are talking about numbers that are not divisible by 2. And what are numbers that are not divisible by 2? The first one is 1. The next one is 2. The first one is 1, next one is 3, next one is 5, 7, and so on like that. So let's write it. This is the operation they say we should do. That means 2 operation 3 will now give us 2 operation 3 will now give us 2 times 3 plus He said plus B. Our A, this is our A. This A, this is B. So A, I'm following the law. 2 times 3. Then what's B? B is what? Is 3. So that will give you plus 3. So what is 2 times 3? 2 times 3 will give us 6. Then they said plus 3. That's plus 3, and this is giving us what? 9. The question you ask yourself is 9 an odd number? 9 is a so we say 9 is an odd number. Therefore, this 2 operation 3 is closed. Do you understand? So that's what close is talking about. The last example I'm going to give now is going to give you something that is not close, so that you will not feel that it's all the time that you get something that is what is close. So let's have this one. If number so this is 1, this is 2, let's say 3. If 2 operation if A operation B is equal to minus A B is, let's say is a real number. Is equal to minus AB, where A and so let's where A and B are real numbers. So we know real numbers. Real numbers are from negative, or we have from 1, 2, 3 like that. Those are real numbers. Now our real numbers. They now say find 2 operation root 6. And you find it. If you find 2 operation root 6 following minus root AB, that will give you minus 2 root 6. If you check minus 2 root 6, it's not a real number. So this minus 2 root 6 is a complex number. Therefore, this is not closed. So you can see that. So in this scenario now, we notice that this is not closed. If A operation B is giving us minus AB, and we are told that A and B are what? Are R. This R represents, when you see capital R like that, is real numbers. So if they are telling you that they are real numbers, so that is your result too. Don't forget, when I was giving definition of a closed form, I told you that A operation B, any operation that you are using at all, if is equal to C, like giving a particular C, your A, B, and C, that is your A, element that you use for A, for B, and also your result must be part of D. That is whatever thing you are being given. On the other hand, if A and B are elements of D, that is A and B, they are part of D normally. And you now have, don't forget, when I told you that real numbers are from your negative numbers to your positive numbers, but it does not involve roots. You understand? So this now, C and C is not an element of D. When you see a cross, it means not an element of D. that means that one is not closed. But when C is an element of D, is still, and we have an example here, A operation B, you can see we are giving where A equals to 1 and B equals to 2, and A operation D, sorry, we are giving if A operation B equals A plus B minus AB. This A, this B, this result is C. If you look at, we have been given D, that this is set of D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you look at A that we are using, find A operation B. If A equals 1, you can see 1 is here. B equals 2, you can see 2 is here. Now, and is A operation B closed under set D? How will you know whether it's closed? That is this result. Whatever the operation of all these ones will give us must be part of D. And when we resolve D, we notice that we got 1, and 1 is still part of D. So therefore, you see is what is closed. So that's just how to solve it. There's no big deal in knowing whether a binary operation is closed or is not closed. So that's how you go about it. The next one I'll be going to, the kind of property which you must know, is what I call cumulative property. Cumulative property. This property is very, very important. It's very, very important, and sometimes learners also have problem with it. So permit me to rub up the whole board so that we can see. Cumulative property. A binary operation is said to be cumulative if A, let me use this operation, that is if A operation B will give you B operation A. What am I saying in essence? This is very simple. What I'm saying is, if you operate A on B, if it's giving you the same answer as when you operate B on A, then you say is what is cumulative. Naturally, you'll be given that binary operation law that you are meant to follow. Maybe this A operation B is equal to A plus B minus 3AB plus C, plus B. That's, we can give you any one. Now, after resolving that, if you go and try, when you change the thing vice versa, and you put B first and you put A second, you see operating following that law and you get the same answer, then you say so is cumulative. That's what we are saying. For instance, under multiplication, the major reason why there are two operations which are usually commutative. The first one is multiplication. The second one is addition. You ask why. Let's see example. Example. If you do 5 times 7, 5 times 7, you notice that it's still the same thing as saying 7 times 5. This will give you 35 equals 35. These are equal. So therefore, multiplication is cumulative. Is cumulative. So we have commutative. It's commutative. Also, if you do this example 1, Example 2. If I do 3 plus 2, you see that it's still the same thing as 2 plus 3. This will give you 5 equals what? 5. Therefore, addition is commutative. So there is no way. If you want to confirm, let's see an example. Let's say you are given A operation B is equal to A plus B minus 2AB. It now asks you to check find 2 operation 3 and is 2 operation 3 commutative. So how will you solve it? Solution. What you do is to do 2 operation 3, 2 operation 3, which will give us, following the law, 2 plus 3 minus 2 times 2 times 2 times 3. So what's 2 times 3? 2 plus 3 will give us 5 minus 2 times 2 is 4. That's minus 4 times 3 will give us 12 minus 12. And what's 5 minus 12? That will give you minus 7. You now check when you change the value, that is 3 operation 2. What will it give us? That's 3 plus 2 minus 2 times 3 times 2. If you check it, you see that this is still 5 minus 2 times 3 is 6, then times 2, that's 12, which is still what? Minus 7. So therefore, this one is what? Is commutative, because you are getting the same answer. Do you understand? You are getting the same answer. That is how you solve this. That's how you solve this. Actually, so on the long run, by the time you want to say, therefore, it is commutative. It is commutative, and you get your answer. But in a situation whereby, yes, say we got minus 7 here and we got 8 here, then you say it is not commutative. I want to believe you are getting my explanation. That you're getting my explanation. So the next one that I would like us to go into is what we call the associative property. So I'm going to rub up the board. Let me rub off the board so that I want to be you understand. But if there's anything that you don't understand, kindly drop a comment at the comment section, or if you feel there's anything that you feel is wrong, yeah, we are all bound to learn. Do you understand? So nobody's an island of knowledge. I can make some mistake while I'm teaching as well. So if there's anything you'd like to point out, just go to the comment section and drop it, and I'll read your message and respond. All right, so let me rub off this. Let's go to associative property. Yes. So, associative property. Just like you know that when you're talking about an association, you can't just be just two, it will be three or more. So now this when association now for this is involving in mathematics is actually involving three elements. So let's say we have in this case a binary operation is associative if a operation, so when you have, it's going to be there's one called associative, there's one called distributive. But in associative, the difference between associative and distributive is associative involves one operation, distributive involves two operations. But here that's A operation, B operation in brackets, B operation C must be equals to, when you first have A operation B in brackets operation C. So that's what associative property is talking about. That is, if you try that, that is meant to give you the same answer. If they give you the same answer, then you say it is what? It is associative. It's associative. So that's how to do that. Then I'll give you us example. But I want us to look at that law very well. Probably copy it down before I give out the example. So let's see something. Let's see this. Is example 1. Is if A, B, C are real, okay, let me write it, real numbers, find if let me think of number to put there. Find if okay, let's just use numbers that follow one another. Find if two operation find if 2 times 3 times 4 is associative. So now we are talking about the operation. The operation here now that we are dealing with is multiplication. So we just want to check, is multiplication, is it actually going to be associative? If you want to do this multiplication, is it going to be associative? Don't forget the law of association. This operation in brackets B and this must be given. So let's see solution. So let's find 2 operation 3 into bracket times 4. So this will give us, let me bring it down like this. So this is 2 times 3, that's 6. Then 6 times 4, which is 24. Let's check the other end. Then we now have it in this way: 2 times bracket 3 times 4. So which will give us 2 times, what's 3 times 4? That's 12. So this is going to give us 24 now. We have 24 equals 24. Therefore, this is associative. So we can check this to know what I'm talking about. So that is associative. So most times under association, multiplication and addition are still like associative. So but let's see another example. Example 2 is 5 times 2 times minus 1 associative. Let's see, is it going to be associative? Let's see if it's associative. Now, the fact that it is times that is there, it will be associative. But in the case whereby you did not put times, let's say what you have there is this 5 times 2 minus 1. In this case, this is not association, but let's confirm. Let's see. That means we will now check. This will give us solution. That's 5 times 2, that will be 10 minus 1, which is what? 9. In the other way, you have 5 times, so you'll be having 5 times, you'll be having 5 times bracket, since this is the operation there, 2 minus 1. Do you understand? This time, so you put the brackets in these 2. So that will give us 5 times, what's 2 minus 1? That will give you 1, and this will be 6. You can see that 9 is not equal to 6. Therefore, not associative. So that's how to go about that. Before I would actually round up, I would like to talk about what I call identity element. That's for this particular topic. In my next class, I will continue. So this is going to be in parts. So this is part 1. In part 1, I'm doing more of explanation of the terminologies under binary. So we've talked about the definition, we've talked about some properties. So let's go into more properties. So before we now, maybe in part 2 now, we'll now be solving past question on binary so that you know how to attempt them. So still on properties. We have identity property. A binary operation is said to have an identity element if A operation E is equal to A. What am I saying in essence? That is, when you operate A on that identity element, you are meant to get A back. So then you now say your identity element is that thing that you have. Are you getting what I'm saying? So instead of writing A operation B, or let me put it, or if A operation B is equal to A, therefore B is the identity element. Example: if number one, if 2 times 1 is equal to 2, find the identity element. So solution, don't forget the law. If A operation B is equal to A, now we have this A, this B, and this one is giving us A back. So therefore, you now say, since 2 operation 2 times 1 is equal to 2, therefore E, which is the identity element, is equal to 1. So that's how we go about it. So therefore, E, which is the identity element, is equal to what? Is equal to 1. If you have any question, drop at the comment section. Don't forget. And please let's share the video. Let me share to friends, and even in your school you can share and connect. And I'm open to online tutorials if you need one as well. I have personal online tutorial. So the last one I'll be showing us now. Okay, I will use distributive property to be my last one, which I told you earlier that distributive property deals with two different operations, not just one. Associative is just one operation, which is going to be either multiplication not true, addition not true, like that. So let's check the next one. That's inverse property. Inverse property. So inverse property. I don't know if you are done with this, if I can rub off. Alright, so let me rub it off now. So the way I tell my learners in school is, when you are dealing with inverse property, I want to know how to handle it. It's very simple. The inverse of any binary operation is gotten by checking if A operation B is equal to 1. Therefore, Therefore, A inverse will be equals to A inverse is equal to B. Example. If I have two operation 1/2 equals to 2 times 1/2, I know that is equal to 1. Therefore, inverse of 2 is 1/2. Likewise, if you have A operation A inverse is meant to give you 1. So anytime that they ask you for the inverse of anything in a book or whatsoever, you are meant to get A operation P to be 1. And this or better still, or if A operation A inverse is equal to E, you know, remember E equals to identity element. This is actually the right one that we should be using. I think this will give you the best. A operation A inverse will be equals to E. The reason why this one is equal to 1, this will be A if A operation A inverse is equal to E. Let's use it that way. I think that's better. That's better. Let's do it that way. So for instance, you know, when we are dealing with identity element, I said firstly 2 times 1 is equal to what? 2. Therefore, E is equal to what? 1. So now, to get the inverse of 2 will now be equals to we now say 2 operation A inverse is meant to be equals to E, and E, but E is equal to 1. Normally 2 times 1 equals to 2 according to law of identity elements. That number will now be your E. Now to get your inverse of this number, then normally you know that 2 operation its inverse is meant to be equals to E. What's the E under this operation? The answer is what? Is 1. So therefore, we now say that 2 times the other operation here is times A inverse is equal to what? 1. Therefore, A inverse is equal to 1/2. So that is that. So that's how you get your answer for A inverse. I believe in part 2, whereby I will be doing more of questions on like past questions and the way they are being set, you get to like understand this more. The last property that I would write here is the distributive property. So I will be ending the class on distributive property. In part 2, we'll solve questions on binary operation, whereby you can be asked find the inverse, find the identity element, check if it's closed, check if it's commutative, check if it's associative, check if it's what? Distributive. So this is part 1. It's all about the foundation that you need for your binary operation. So let's see the last one here. The last property, which is what? The distributive property. Distributive property. Now, if you want to deal with distributive property, let me just go straight to the point. deals with two signs or symbols. E.g. let's use aesthetic. Okay, let's use plus and aesthetic operation in this place. So example 1. Now this one, like this. If distributive, then A operation B or let's say, let's do it this way. A operation B in brackets B operation C will give you A operation B, then we put this operation A operation C. That's distributive. And vice versa. If you have A operation B operation C, it must be equals to A operation C, then aesthetic it must be equals to A operation C operation B operation C. So e.g. is 2 times 3 plus 2 distributive. So you now check. So this is what distributive is saying. It must involve two sides. That's the first thing. The second thing is that when you distribute A or B, the signs will change. Like now, A operation B and aesthetic C, it will be A operation this and operation A operation C, and they must give you the same answer. If they don't give you the same answer, there is not distributive. Don't forget, if they don't give you the same answer, they are not distributive. So let's see solution. So you have 2 operation. Sorry, let's use 4, not the same number. So plus 4. Let's add that. So if you going to be distributing, that means this should give us 2 plus 4, then times 3 plus 4. These two should give us the same answer. Let's now see if truly it will give us same. Now let's check whether it is distributive. So this is telling us that, if you look at this, is multiplication distributive over addition. This multiplication over addition, you check whether it is distributive. According to the law, that will be, this is 2 times 3 plus 4, just like this one, which must give us 2. We use the operation outside. Don't forget, operation outside, that's A operation C. So this will now give us 2 up plus 4, then times 3 plus 4. So what's 2 times 3? That's 6 plus 4 is equals to 2 plus 4. That's 6 times 3 plus 4. 3 plus 4 will give us 7. This will give us 42, and this one will give us 10. 10 is not equals to 42, therefore not distributive. That will be your answer. But there are instances. Okay, now for instance, let's now change it vice versa. Vice versa. What am I saying? Instead of having multiplication inside, let's have it outside. Whether it's going to work out. So let's check. Let's check it like that and see whether it's going to work out. So example 2. Is 2 plus 3 times 4 distributive. So let's check. So solution following the same law. So this will now give us 2 times 4 plus 3, 2 times 4 plus 3 times 4 is equals to 2 plus 3 times 4. So 2 times 4 will give us, 2 times 4 is 8 plus 3 times 4. 3 times 4 is 12, abi? Then 2 plus 3 is 6. 6 times 4. So this one is going to be 8 plus 12. This is 20. And 20 is not equals to 6 times 4. 24, so not distributive. So this is where I will be stopping for today. This is where I will be stopping for today. So if you have any question or any observation, you can kindly drop at the comment section. It is King of Mathematics. On to the next video. Make sure you subscribe. Please make sure you subscribe, share to friends that are lovers of mathematics as well. Then you can always drop any topic you want me to treat in my next class. But this is part 1. Part 2 I'll be solving past questions so that we'll see how to attempt them. On to the next video. I say bye.